This video is for Chapter 6, Section 6.4 for the math activity Irrational Numbers on Geoboards. We'll use rectangular geoboards and explore irrational number lengths. If you don't have a geoboard handy, and those are nice to use, you can use geoboard paper. It's available on our website and linked below the video. In the first question, we define a square unit. This square is 1 square unit. The edges of the square are each 1 unit. This is a 5-pin by 5-pin or 4 by 4 because we're measuring these lengths geoboard, and we want you to find the area of the other figure. I have that figure divided up here into squares and triangles. These triangles are half a square or half a square unit. This triangle is half of this rectangle with 2 square units, so this triangle is 1 square unit. Just a little detail on that. In number 1, we ask you to form figures of 4 different square unit areas that we give you. In number 3, we ask you to form triangles with different areas. Here's another triangle example. This is a 4 by 3 rectangle, so this triangle is half of 12 or 6 square units. In question 4, we ask you to form squares on the geoboard, and we have a list of the squares that are possible on these 5-pin by 5-pin geoboards. Notice this square, we can determine the area in a different way. If you draw another square outside of this square, that's a 3 by 3 square outside, or 9 square units. These corner triangles all have area of 1 square unit. 9 minus 4, this inner square is 5 square units. And so this is just a hint that you can do this for others. Then in question 5, we talk about irrational numbers. The area of a square is the product of the length of one side and the length of the other. This square has an area of 5 square units, so we need a number that when multiplied by itself yields 5. We call this number the positive square root of 5, and we write this with the square root symbol 5. Therefore, this line segment here, AB, the length of the edge of the square of area, 5 square units, is square root of 5 units long. And we further note that the positive square roots of all whole numbers that are not perfect squares are irrational numbers. And so label all your sides with the lengths and note for yourself which ones are irrational. For example, 4 is a perfect square, so is 1. So you won't get irrational numbers here. For example, here is a square of area 2 square units. You can see I could divide that into 4 triangles, each of which are a half a square unit. So that's my 2 square unit square, so therefore the lengths of each side are the square root of 2. Then in number 5, we ask you to use your squares to show that the square root of 8 is 2 times the square root of 2. And here's a little pictorial hint for you. The square root of 2 plus the square root of 2 is equal to 2 times the square root of 2. That makes sense. It's just like adding variables slightly. And you can see in this picture that this length is the square root of 2 and this length is the square root of 2. So you can use this hint to complete number 5. I hope you have fun with this math activity, working and learning to work with geoboards and thinking about irrational numbers.